Welcome to the CMIC3 video for the logarithm worksheet for May 19th. I'm going to work problem 13 for you. Then I'll let you work problems 14, 15, and 16. Problem 13, we have to use the properties of logarithms again. The only way to solve an equation is to get rid of the logarithms, and we need to have one logarithm on each side to do that. So if I look at the problem in 13, I have log of x plus log of 9 equals the log of x plus the log of x plus 17 equals the log base 9 of 38. So I need to combine this into one log before I can raise it to that, raise 9 to this power. I do that with the properties of logarithms. The sum of the logs is actually equal to the log of the products. If you remember, the result you get from a logarithm is an exponent, and when you multiply expressions, you add the exponents. So adding logarithms is like adding exponents. So I can say this is the log base 9 of x times x plus 17. Instead of saying it's the sum of the logs, I say it's the product, the log of the product of x and x plus 17. And I know that's equal to the log base 9 of 38. And before I go too far, I will subscript my 9s. And now I have a single logarithm on both sides. I can raise both, the correct way to say this, I can raise 9 to the power of each side of the equation. So I'm going to cheat and put my, copy my expression. So I'll raise 9 to this power. And then I will raise 9 to this power. So I have 9 to the logarithm base 9 of each side. Raising to the 9th power is the inverse of the log function. That's why the result of the log function is an exponent. They undo each other. So I can just cross out the 9 to the log base 9 power. I have x times x minus 17. Before I go too far, I will turn off the superscript. And that is equal to, on the other side, 9 to the log base 9 power cancels itself out. I just have 38. Now I have to distribute. I'm trying to get x by itself. The first thing I have to do is get rid of the parentheses. I take this x and I multiply it by this x. Then I multiply it by the 17. So I have x squared minus 17x equals 38. And some of you may recognize that. Hopefully everyone recognizes that. This is it's now a quadratic equation. When you have a quadratic equation, you have to get it equal to 0. You have to have one side equal to 0 when you solve it. So I'm going to subtract 38 from both sides. And that gives me x squared minus 17x minus 38 equals 0. Now, to solve that, we need the quadratic formula. There are other ways to do it, but the quadratic formula is about the simplest. So let's do the quadratic formula. Quadratic formula, you need A, B, and C. So A equals, A is the coefficient of the x squared term. Since there really isn't one here, I'm going to say that's equal to 1 times x squared. So I'm going to say A is 1. B is the coefficient of the x term, which in this case is negative 17. And C is the number that's by itself. So C equals negative 38. Since it's minus 38, C is negative 38. Now, the quadratic formula is x equals negative b plus or minus, I'm going to say that this way, plus or minus the square root, and since I'm doing this on the computer, I'm just going to say square root of b squared minus 4ac and since I'm doing it on one line, I need to put parentheses around my numerator. Typically, you would see this in the top of a rational equation. But I'm going to use the slash for my divide, and I'll divide by 2 times a. So that's my formula. Negative b plus or minus the square root of the quantity b squared minus 4ac. That entire expression divided by 2a. So I'm going to plug my numbers in. X equals negative b is negative of negative 17. Negative 17 times negative 1 is plus 17. And again, I'll say plus or minus square root of b squared is now negative 17 squared. But when we square a negative number, we get a positive number. So I could have just put 17 squared, but just to be clear, I did negative 17 squared minus 4 times 1 times c, which is negative 38. And that's going to be my numerator. And I'll divide it by 2 times 1. And a is 1, so 2 times 1 is 2. I'm just going to write 2. So now to evaluate this, I go to my calculator. I'm going to end up saying that x equals something, or it equals something else. And I will get my calculator to see what it equals. So I bring my calculator over. So 17 squared. Actually, I'm going to start with this part of the expression, the square root, because that's what I'm going to subtract or add. So I want to have that number first. I'll put that in my calculator. So yeah, 17 squared minus 4 times, I could say times 1, but that's just 4. So I'm going to say 4 times 1 times negative 38. 38 negative. So my calculator is going to square 17, multiply 4 times 38, negative 38, and then subtract that value. And I get 441. If I take the square root of that, I get 21. Plugging that in, actually I'm going to put that in memory. I'll put that in my memory because I'm going to use it twice in two different equations. So my first one is 17 plus that value, plus that square root of 41. So 17 plus memory recall equals 38 divided by 2 equals 19. So according to this, x can equal 19. And to get the other value, I go back to the calculator and I start off again 17. This time I'm going to subtract the square root. So I do 17 minus 21 and divide that answer by 2. So I get x could equal -2. And a lot of people will be satisfied with that, but I'm going to go back and check the original equation. I'm going to take this equation. I'm going to try both of those values. 19 squared minus 17 times 19 minus 38. And I'm going to see what that equals. Once again, I'll go back to my calculator. 19 squared minus 17 times 19 minus 38. And I can already see that's going to give me 0. So 19 works. I'm going to try -2 now. So I'll go back here, and that did equal 0. So that checks. And I'll do 2 squared minus 17 times 2 minus 38. And I will see if that does in fact equal 0. So 2 squared minus 17 times 2 minus 38. That does not equal 0 because I needed -2. So that will change our problem. Let me check that. -2 squared. I'm still going to do 2 squared because -2 squared is the same as +2 squared minus 17 times, in this case, -2. And then I'll subtract 38. So I can see that once I put the correct values in, -2 does in fact give me 0. So I know that the original equation would be true if x equals 19 or x equals -2. Try 14, 15, and 16 now, and let me know how you do. Thank you.